I call this experiment the salt meter because it's designed to measure the relative concentrations of salt in water. Now you can see I've got a beaker here with exactly 100 grams of water, that's 100 millilitres of water of course, two aluminium electrodes connected to a 3-volt DC, so low voltage power supply, and a multimeter set to 200 milliamps, right? 200 milliamps. Now, at the moment, there's 1.1, 1.2 milliamps of current flowing through, but watch what happens now when I add some salt to the water. I've actually added only 0.3 of a milligram, so it's very, very little, 0.3 of a milligram. Look at the current. The current is steadily climbing as the salt dissolves in the water. Now I'll give it a stir to help it along, and you see the current is going up. A point will be reached where all the salt has dissolved. Now remember, that was only 0.3 of a gram. So when all the salt has dissolved, you should take a reading. Then throw that water away, start again with fresh water and with a different mass of salt. And repeat the process if you can, starting at near a 0.1 of a gram and going through to, at most, I would think a gram, because you don't really want to have more than, well, maybe half an amp flowing through the liquid, preferably rather less. Then calculate the concentration of salt. Now I've got 100 grams or 100 millilitres of water in there, and I'm putting in, as I said, tenths of grams of salt. So plot a graph of concentration against the current, and this will give you a calibration graph for salt concentration in water. Hence the name the salt meter.